I'm Ahmed Daud, and in the last session, we have seen hyperparameters, or you can say parameters from the SQL decision tree classifier. Okay, so regarding the regression, there is just one change that I have told you regarding the criterion, and all the remaining concept is the same. Okay, so in this session, I will tell you about some of the attributes of that are provided by sklearn and their methods that are listed here. And regarding the coding part, I will give you some. Here we will do some little bit code. We will do some parameter, pass the some values to the parameter, and see the what is the behavior of decision tree, how what type of decision trees we are getting here. But all of them I will not implement. You can play with that. The concepts are the same that I have explained in the last session. Okay, so there is a attribute classes. You can use that classes if you want to see after the classifier. You want to see that what classes I have passed. Feature importance. Okay, so feature importance is one of the attribute. This is not much of you can say quite a reliable attribute. You can use that attribute. It can return the feature importance. Let's say if you have two input variables, or let's say five input variables and one target variable, and after the you can say training of decision tree, you can ask the decision tree what which feature or which input variable is more important compared to all other features. Okay, how it calculate, actually it calculate the importance of feature by computing or by analyzing that total reduction of the criterion. Like if you have five features, and during the training process, each feature can be used at some stage for the splitting purpose. So how much each feature has done the reduction in the impurity of the whole tree. Okay, so it will calculate for each feature total reduction in impurity for the whole tree, then it normalize that and give you importance of the features in the form of some percentages, some decimal values. Okay, so but it is not reliable because at each split point there is again there are some randomness in our model, because if you some multiple split values or split points are giving the same type of Gini impurity and they are the best split values, then it pick one of them randomly. So that's why this feature importance is not much reliable. Okay, so next one, max features. If you have passed some value here max in the your parameter max feature by using square root or log or some other, by using some fraction, you can see the max features attribute by using that max feature attribute or by your classifier that you have trained, that what inferred value of the max feature during the training process. Okay, let's say you have passed here some fraction by multiplying the fraction with the total number of samples, yeah, and what value actually sklearn or model has inferred from that fraction. You can ask that by using that attribute. Okay, so how many number of classes, you can see what are the features that are number of features that we pass during the training part. What are the names, what are the number of outputs when fit is performed, and tree. So this is also a attribute that return tree instance. It is quite interesting. If you want to explore, you can explore it by yourself. I can give you here an idea. From here you can see the examples also. So you can also by using that tree attribute and then a tree instance, classify dot tree instance, and then you can access their attributes. It can tell you a lot of information, how many nodes our tree has created, what are the child's, how many left child's, right child's features and thresholds. This type of internal information you can access by using the attribute of that tree, and you can see the examples from here also. Okay, so there is also some methods here. like apply method. This apply method can tell you which leaf node has predicted that particular sample. Okay. Cost complexity pruning path, we will this is associated with the post pruning part, so we will discuss in that post pruning lecture. Decision path, it actually can tell you the whole decision path, how your sample is predicted. Fit for the training purpose, get depth, it can tell you the depth of the tree. Get and leaves number of tree. Get parameters can tell you the parameters. Predict, these are the common functions. Predict can tell you the can use for the prediction purpose. Predict probe, it can give you the probabilities against each class. We will also see how it actually calculate the probabilities for each class, the decision tree. So log of the probabilities you can get from this by using that method. Score if you want to see the accuracy, and if you want to set the parameter after defining your actual model, you can again set the parameter by passing the values here. So these are the methods you can explore by yourself. These are not much of you can say much difficult or complex to understand. Okay, so I will give you here an idea. First, I am importing some important libraries here. I have a data set which is a iris data set, and it has so four columns. I am just going to use two columns for the simplicity: petal length and petal width for as input variables, and species will be my output variable. So here df1 dot ilog, I am just getting my these input variables and just three columns, two inputs and one out. So there are 150 total number of rows, and petal length, petal width, species, all of species is object of object type. It means it's a categorical. I told you we are curious about the input variables. In classification case, we should convert this into some numerical form. Regarding the target variable, our model or sklearn in the case of decision tree can do by itself. Okay, it can convert it internally by itself into some numerical form if needed. So remaining input variables are already in the numerical form. So here we are splitting into x and y. Then we are splitting into test and train data set. Now we have 105 data points for the training and other for the testing purpose. And here you can see the scatter plot of the training data points. Here I am going to use a decision tree classifier, and here I am mentioning random state is equal to 1, so that whenever I will again run that code, I will get similar type of the decision tree. And here I am passing my training data set, and here you can see classified dot classes attribute is giving you like what are the classes that your data set contain, and feature names in that tell you the what are the features you have passed here. And then I have used the same plot tree function to see the tree. Okay, so here one important aspect that I want to tell you here, if you will see that particular node number 13, it is 0.444 have gene impurity, but as you know, here I have not passed any parameter values here. So it should keep on splitting until there should be a gene impurity 0. But here you can see here gene impurity is 0.444, but it has not further splitted. And you can also see the values. There is one sample belonging to the versicolor and two samples belonging to virginica, but it has not further splitted. The reason is that I told you it keeps on splitting if there is some decrease in impurity, or you can say until to get pure leaves. But here both cases are true, but there is some gene impurity, and there is but it has not further splitted, as we also have not restricted this tree by passing some values to the hyperparameters. The reason here is that I will show you in a while also. There is no valid partition is available here. On the basis of that, it can split. Okay, so that's why it has not performed the splitting here. I will show you here. Here you can see data the point that have petal width greater than 0.8 and petal length width greater than 1.75, and the petal length less than 4.85 means any sample that have the petal width greater than 1.75 and petal length less than 4.85 will reach to that node number 13. Okay, so I am just using that conditions. Okay, so just to visualize what type of data points are available here, the three data points. So petal width less than 1.7 less than equal to 1.75 and petal length less than 4.85 here. Petal width should be here. Here, petal width, the points that have not less than 0.8 will be here, and the points that have not petal width less than 1.8 here. Okay. So here that's why I have mentioned here negation, so that it is negating that. Means I want data points that have not petal length less than 1.75 and the condition that have petal length less than 4.85. When I will run here, you can see there are three data points, and you can see here in each feature value there is same type of values. Okay, petal length have same values and petal width have same values, so there is no any split valid partition is available. If at least there should be a two values so that it can pick midpoint of them in some feature as a valid partition, but there is no available here, so that's why default model has or default algorithm has not split that particular node into point further. Okay, so here I can show you this one also, that you can use a predict function here to see the their you can say output. Like here it is saying Virginica is output, and if you will use a predict proba function here, and I am passing 4.8 and 1.8, it can give you the probabilities. Here it is saying that 0% probability belonging to Stosa class, 0.33% belonging to the versicular, and 0.67% chance is belonging to Virginica of that sample. So that's why the more percentage chance of the Virginica, so that's why it has predicted as a Virginica. How these probabilities are calculated? The probabilities are calculated by in this way. Here you can see at that particular node there are values 0, 1, 2. So it means that there are zero number of samples belonging to Stosa class, one number of samples belonging to versicular, and two number of samples belonging to Virginica. So when you will divide by 0 by 3, 1 by 3, 2 by 3, you can get some probabilities. Like total number of samples at this node is are 3, and then you will divide a number of samples of each class by total number of samples, then it can give you the probability. So in that way this predict probability function calculate the probabilities in the case of decision tree. Okay, so here get depth function you can use to see the depth of the, like here the 5 depth and number of leaves are 8. You can see here 1, this is at this stage there is depth 1, at this stage depth 2, depth 3, depth 4, and this stage depth 5. And number of leaves, it is saying that there are 8 leaves, so we can here see 1, 2, 3, 4, 5, 6, 7, 8, and how we yeah, 8, there are 8, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there are total 8 leaves. You can use that get n leaves method. Okay, so now for as I told you in the last session, you can export the image of a decision tree as a dot file, and then you can run the command to convert into some PNG format. If you want to do, you can do it by yourself. Okay, here I am passing here restricting my decision tree to the maximum depth 2. Now if I will show you here, you can see my decision tree have depth 2. If I will restrictive that it should have 6 number of leaf nodes, then you can see here my decision tree will have 6 number of leaf nodes on the in the form of best first fashion. Okay, so here 1, 2, 3, 4, 5, and 6. 6 leaf nodes it has, and further leaf node it has not produced because we have here put the restriction on the growth of the tree, that it cannot grow the tree which has more than the 6 leaf nodes. You can also play with the other values, like here I have used mean impurity decrease 0.01, And here this type of tree I got here, and I can tell you here how the mean impurity decrease work. Like theoretically I have told you, like if you will consider the node number 9, this one, there is a 0.444 gene impurity at this particular node, and 0 impurity in the left child, and 0.444 in the right child. So if you will calculate a 0.444 multiplied by 3 number of samples divided by 6, and 0 multiplied by 3 divided by 6 total number of samples at this node. So this will be the gene impurity of the their branches, or you can say their childs of this node number 9. Then you will subtract from node number 9 impurity 0.444, and then multiply to see the how much the decrease in impurity of overall tree. Then multiply it by 6 divided by 105, that are for total number of samples. Okay, so here it is 0.012. So as 0 point, or you can estimate 0.013, as it is greater than 0.01 that we have mentioned here, mean impurity decrease, so that's why this split is allowed here. Okay, if you will increase, you can say increase this, let's say 0.02, this 0.02, then you will not get any split that have impurity, you can say less than 0.02 decrease in impurity. Okay, so you can see here, but if I will run it again, maybe I will get some different type of model. I can see here if I run this with the 2 0.2. Yep, here it has produced a different type of you can say model, depending upon their gene impurity, because it has not created the further separated all of these nodes that are generating that are having less than decrease in impurity less than 0.02. But if I will mention, I can get my tree that I was having previously. Okay, so you can also put the restriction by mentioning mean impurity decrease. Okay, predictive function, I can tell, I have told you, you can pass here the whole test data set, and you can get the predictions. Now I was saying you about the apply method that is available here. You can use apply method if you want to see at which node, or which node particular node has predicted this versicolor. Okay, it is saying that apply method is saying here I have passed all the my testing input variables, input data, and it is saying that node number 4 has predicted versicolor, and you can cross check it. Like I am using here classifier 5. So here you can see at the node number 4 there is a class is versicolor. So this node number 4 has predicted this versicolor class. Okay, in this way you can also get the nodes nodes index uh, which has predicted these classes by using apply method. Okay, so there is another method which is a decision path. Here I am just getting my input values of at present at the 73 index of test data set, which is 4.7 petal length and 1.2 petal width. Yeah, so true value of that sample is iris versicolor, and I am predicting by my model it is again iris versicolor. When I have use apply method is saying that this iris versicolor is predicted by the node number 4 present in the decision tree. So if I will pass this input values in the decision path function that is available here, you can also explore here decision path function. As I told you previously that this can tell you the whole path, how your whole path, how your input values or your sample is predicted as iris versicolor. It is saying here you can see this is returning a sparse matrix. When you will print that, you can see here 0 0 0 2 0 3 0 4. It is actually sparse matrix, which is one dimensional matrix, and it is saying that your sample goes started from 0, then go towards the 2 and 3 and then 4 number node, and hence your prediction is done. In that case, like here your sample data I have passed here, sample number 70 that is present at 73 index I have passed here. it started from here, node number 0, then go towards the node number 2, then went towards the node number 3, and then went towards the node number 4. Hence, iris versicolor is predicted by this model. Okay, it is telling you the whole path. Okay, so this is as a sparse matrix. That's why this type of notation it is mentioned here. Actually, if you will convert that sparse matrix into some dense matrix, it will be like this. Okay, it is a one-dimensional matrix, and all the position, like at the 0 0 position there is one, at the 0 2 position there is one, at the 0 3 position, at the 0 4 position there is one, and all other positions have zeros. Okay, so as a dense matrix have give you take a lot of space, and that's why sometimes some methods are returning sparse matrix, and that can tell you easily that how your sample is predicted in this decision tree. Okay, so it went from the 0 node, then went towards the node number 2, then node number 3, and node number 4, and node number 4 has predicted, you can see from apply method, predicted that your sample that you have passed is belong to iris versicolor, and true value is also saying that your sample is iris versicolor. Okay, so feature names, you can see. Okay, this is feature importance. If you will run the feature importance attribute, it can give you the importance of the which feature has how much importance, like it is 57% important, and it is 42% important. Okay, according to that particular decision tree classifier 5. And as I told you, how it actually calculate, this is not much reliable on large scale, this feature importance attribute, because as I told you, it calculate the feature importance on the basis of total reduction in the impurity by that particular feature. Okay, and then normalize that into to bring into the range of the probabilities. Okay, remaining all other like a lot of here parameter that I have not used here. You can play with these parameters. These are the same, like I told you, same concepts are here. And some of the parameters like a separator max features, these are the to create some randomness, and class weight and mean impurity decrease. As I have not passed here any class here, you can see here sample weights during the training phase. I have not passed any, you can say, sample weights, and I have not mentioned here the class weight is equal to balance. So that's why there is no class weight or sample weight associated to each sample. So that's why I have not used that weighted fractions or minimum impurity. Oh, sorry, this one I have used. This one like a mean weight fraction leaf, and this that are associated with the weights particularly. Okay, you can play with that with some different data set, and these are the pretty much same concept that I have told you here. Okay, and you can read that this documentation also, and the documentation that I have told you last time also. You should have a look on this documentation. Okay, so for now, we have learned all the hyperparameters available by the sklearn, and for the pre-pruning part, first concept is to understand the hyperparameters. Then the second part will be grid search CV, so that we can pass some specific range of values to each parameter, and then we will run the grid search CV to get some good combination of value and to avoid the overfitting of the decision tree. So far now, thank you.